Hello everyone, welcome to all of you. In the last lecture we have completed our derivatives of composite functions. Today we will learn about derivatives of inverse functions. Firstly we will see what is inverse functions. In the previous standard we have studied about various types of functions. Inverse functions means if y equal to f of x be a function of x and which is 1, 1 and onto, then the inverse of this function exists and which is given to be x equal to f inverse of y. The theorem on inverse function is, statement of the inverse function is, suppose y equal to f of x is a differentiable function of x on an interval I and y is 1, 1 on 2 and dy by dx is not equal to 0 on the interval I. Also if x equal to f inverse of y is differentiable on f of I, then dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. This is the statement of the theorem. This statement can also be given as if y equal to f of x is a differentiable function of x such that inverse function x equal to f inverse of y exists, then x is differentiable function of y and which is given as dx by dy is equal to 1 upon dy by dx when dy by dx is not equal to 0. Here meaning of both the statements is same. In this statement given as y equal to f of x is a differentiable function of x, that means dy by dx exists and which is not equal to 0, and inverse of given function exists which is given as x equal to f inverse of y, and we have to prove that here this x is differentiable function of y, that is dx by dy exists and given as dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. Let us see proof of this theorem. Firstly, we have to consider increments which are included in the statement. Here x and y are two variables, therefore delta x and delta y with the increments. So let us consider, firstly we have to consider first increment delta x. Let delta x be the small increment in x. Let delta y be the corresponding small increment in y. As delta x and delta y increments, delta x is not equal to 0 and delta y also not equal to 0. Theorems on composite function मध्ये आपण यापूर्वी पाहिलेला आहे. जेवढे व्हेरिएबल्स इन्क्लूड होत असतील तेवढ्या इन्क्रिमेंट्स आपल्याला कन्सिडर करायचे असतात. पुढे कंटिन्यू करूया. Since this is delta x and delta y are small increments, therefore consider the incrementary ratio delta x upon delta y into delta y upon delta x. इथं कॅन्सल होऊन is equal to 1 येऊ शकतं, आपण जस्ट कन्सिडर केलेलं आहे. Therefore delta x upon delta y is equal to 1 upon delta y upon delta x, and assume here delta y upon delta x not equal to 0. Now taking limit as delta x tends to 0 on both the sides, we get limit delta x tends to 0, delta x upon delta y equal to limit delta x tends to 0 1 upon delta y upon delta x. As delta x tends to 0, delta y tends to 0, therefore replacing this delta x by delta y, limit delta y tends to 0 delta x upon delta y equal to limit delta x tends to 0 1 upon delta y upon delta x. Therefore limit delta y tends to 0 delta x upon delta y equal to 1 upon totally limit delta x tends to 0 delta y divided by delta x. Consider this equation as equation number 1, and in the statement of this theorem given as y is a differentiable function of x. So what is the meaning of y is differentiable function of x? That means derivative of this y with respect to x exists. Therefore dy by dx exists, and this dy by dx is given as limit delta x tends to 0 delta y upon delta x equal to dy by dx. Therefore equation 1 becomes, replace this term as dy by dx. Equation 1 becomes limit delta y tends to 0 delta x upon delta y equal to 1 upon dy by dx, and delta dy by dx is not equal to 0. Now consider this equation as equation number 2. Now observe the RHS of equation 2. Since here the denominator of RHS is dy by dx, which is derivative of y with respect to x, this exists, that means limit exists, and which is a finite term. Therefore since RHS exists, LHS of this equation exists, that means this limit exists. Therefore as RHS of equation 2 exists, then LHS also exists. Therefore limit delta y tends to 0 delta x upon delta y exists, and which is equal to, by Leibniz notation, it can be expressed as dx upon dy. Substituting this value in equation 2, therefore equation 2 becomes dx by dy is equal to 1 upon dy by dx, where dy by dx is not equal to 0. This is the proof of the theorem. Here proof is very easy. तुम्ही 2-3 वेळा प्रॅक्टिस करा, तुम्हाला याचे 3 पैकी 3 मार्क मिळू शकतात. 3 मार्क्ससाठी हा theorem येतो. Now we will see derivatives of inverse trigonometric functions. आतापर्यंत ट्रिगोनोमेट्रिक फंक्शन्स फक्त वेल नोन आहे तुमच्यासाठी. टॉपिक आपला पेपर फर्स्ट आहे, त्यामध्ये ट्रिगोनोमेट्रिक फंक्शन्स चॅप्टर येईल. त्यामध्ये इनव्हर्स ट्रिगोनोमेट्रिक फंक्शन्सचं पूर्ण स्टडी आहे. जर x इक्वल y इक्वल टू साइन x या टाईपमध्ये फंक्शन असेल तर त्याचा इनव्हर्स फंक्शन साइन इनव्हर्स x, y इक्वल टू कॉस x असेल तर x इक्वल टू कॉस इनव्हर्स y, या टाईपमध्ये इनव्हर्स फंक्शन्स एक्झिस्ट असतात. टेक्स्टबुकच्या PDF फाईलमध्ये या इनव्हर्स ट्रिगोनोमेट्रिक फंक्शन्सचे जे डेरिव्हेटिव्ह आहेत त्याचे कंप्लीट प्रूफ्स आहेत. तुम्ही एकदा ओव्हरलुक करा. आपण इथं आपल्याला जेवढे फॉर्म्युले युजफुल आहेत तेवढे समराइज केलेले आहेत. डेरिव्हेटिव्ह्ज ऑफ इनव्हर्स ट्रिगोनोमेट्रिक फंक्शन्समध्ये 1 by 1 सगळ्या फंक्शन्सचे डेरिव्हेटिव्ह इथं राईट केलेले आहेत. डेरिव्हेटिव्ह ऑफ साइन इनव्हर्स फंक्शन इज डेरिव्हेटिव्ह ऑफ साइन इनव्हर्स x इज 1 upon root of 1 minus x square. Derivative of cos inverse is same as derivative of sin inverse, but here minus sign is extra, minus 1 upon root of 1 minus x square. Similarly tan inverse आणि cot inverse चा डेरिव्हेटिव्ह सेम फॉर्म मध्ये येणार आहे, 1 upon 1 plus x square, 1 upon 1 plus x square. cot inverse x साठी फक्त -1 आहे. Similarly derivative of sec inverse x is 1 upon x into root of x square minus 1, and derivative of cosec inverse x is -1 upon x into root of x square minus 1. ज्यावेळेस डेरिव्हेटिव्ह्ज ऑफ स्टँडर्ड फंक्शन्स आपण पाहिलेले आहेत, डेरिव्हेटिव्ह्ज ऑफ ट्रिगोनोमेट्रिक फंक्शन्स, त्यावेळेस एक ट्रिक सांगितली होती मी यापूर्वी. जर ट्रिगोनोमेट्रिक फंक्शन्समध्ये c येतो त्या केसमध्ये इकडचा डेरिव्हेटिव्ह निगेटिव्ह येतो. तोच क्रायटेरिया इथे यूज करायचा आहे सेम. म्हणजे ज्यावेळेस तुम्हाला आठवत नाहीये की कुठल्या फंक्शनचा कोणत्या फंक्शनचा डेरिव्हेटिव्ह निगेटिव्ह येतो, तर फक्त एवढं लक्षात घ्यायचं की कॉस इनव्हर्स, कॉट इनव्हर्स आणि कोसेक इनव्हर्स या 3 फंक्शन्सचा डेरिव्हेटिव्ह निगेटिव्ह लिहू शकतो आपण. ठीक आहे. डेरिव्हेटिव्ह ऑफ इनव्हर्स ट्रिगोनोमेट्रिक फंक्शन्स बरोबरच आपण काही फॉर्म्युले परत डिराईव्ह करायचे आहेत. ते पुढे आहेत. डेरिव्हेटिव्ह ऑफ इनव्हर्स कंपोजिट फंक्शन्स. ऑब्व्हियसली कंपोजिट फंक्शन्सचा पार्ट तुम्हाला क्लिअर असेल. कंपोजिट फंक्शन्समध्ये काय येणार आहे आता, हे जे इनव्हर्स फंक्शन आहे त्यामध्ये परत एक अनदर फंक्शन. सिंपली composite functions means a function of another functions, and meaning of inverse composite function is inverse trigonometric functions मध्ये जे फंक्शन येईल ते परत इथं दुसरं फंक्शन एखादं येणार आहे. इथं f of x ऐवजी मे बी log x, 2 raised to x, सॉरी एक्सपोनेन्शियल फंक्शन येऊ शकतं, a raised to x, e raised to x, किंवा एखादं अल्जेब्रिक फंक्शन येऊ शकतं. पुढे एक्झाम्पलमध्ये ज्यावेळेस येईल ते आणखी क्लिअर होईल. या फंक्शनचा डेरिव्हेटिव्ह डिराईव्ह करताना तुम्हाला प्रिव्हियसली जसं कॉम्पोजिट फंक्शनमध्ये आपण अभ्यास केला त्याच टाईपमध्ये डेरिव्हेटिव्ह ऑफ साइन इनवर्स, कॉस इनवर्स किंवा सिंपल इनवर्स फंक्शनचे डेरिव्हेटिव्ह तुम्हाला वेल नोन पाहिजेत. डेरिव्हेटिव्ह ऑफ साइन इनवर्स इज 1 upon 1 minus x square. So if we have to find derivative of sine inverse of f of x, replace this x by f of x. Therefore the derivative of sine inverse of f of x is 1 upon root of 1 minus f of x bracket square into, and by derivatives of composite function multiplied this derivative by the derivative of the given function, that is f dash of x. Similarly, derivative of cos inverse of f of x is minus 1 upon derivative of cos. Here is c is present, therefore its derivative is minus 1 upon root of 1 minus f of x square into derivative of f of x is f dash of x. Similarly, derivative of tan inverse of x is f of x. Derivative of tan inverse of f of x is 1 upon 1 plus f of x square into f dash of x. Derivative of cot inverse of f of x is minus 1 upon 1 plus f of x square into f dash of x. Derivative of sec inverse of f of x is equal to 1 upon f of x into root of f of x square minus 1 into f dash of x. And finally, derivative of cosec inverse of f of x is equal to minus 1 upon f of x into root of f of x square minus 1 into f dash of x. So these are the derivatives of inverse composite functions. हे फॉर्म्युले आपल्याला ॲक्च्युअल एक्झाम्पल सॉल्व्ह करताना यूज करायचे आहेत. यानंतर आपण बघूया डेरिव्हेटिव्ह ऑफ इनवर्स फंक्शन वरती डिपेंड असणारी एक्सरसाइज 1.2. नाउ वी विल स्टार्ट एक्सरसाइज 1.2. द क्वेश्चन नंबर 1 इज फाइंड द डेरिव्हेटिव्ह ऑफ the function y equal to f of x using the derivative of the inverse function x equal to f inverse y in the following. या क्वेश्चन मध्ये असं दिलेलं असणार आहे y equal to some function आणि या y equal to जे फंक्शन असेल याचा डेरिव्हेटिव्ह विथ रिस्पेक्ट टू x फाइंड आउट करतोय आपण. ऍक्च्युअली याचे डेरिव्हेटिव्ह सिंपल वे मध्ये आपण फाइंड आउट करतोय, बट इथं प्रोसेस यूज करायची आहे युजिंग द डेरिव्हेटिव्ह ऑफ इनवर्स फंक्शन. डेरिव्हेटिव्ह ऑफ इनवर्स फंक्शनचा यूज करून कंपल्सरी इथं डेरिव्हेटिव्ह फाइंड आउट करायचं आहे. सपोज फर्स्ट एक्झाम्पल y इक्वल टू रूट एक्स, and you know that derivative of root x, derivative of y with respect to x is dy by dx. Derivative of this root x is directly, you know that 1 upon 2 root x, but we have to solve this example by using derivatives of inverse function. So let us see the solution of this example. Given y equal to root x, फर्स्टली पहिल्या स्टेप मध्ये इथं कन्सिडर करायचं आहे y इक्वल टू रूट एक्स. इथं जो y गिवन असेल त्या रिलेशन वरून x इक्वल टू टोटली टर्म आपल्याला फाइंड आउट करायचे आहे. ओके, y इक्वल टू रूट एक्स स्क्वेअरिंग ऑन बोथ साइड्स, y स्क्वेअर इक्वल टू x. देअरफॉर कन्सिडर x इक्वल टू y स्क्वेअर. x इक्वल टू f इनवर्स ऑफ y. नाउ दिस x इज एक्सप्रेस्ड इन टर्म्स ऑफ y, which is inverse of given function x equal to f inverse of y equal to y square. Now differentiate this x with respect to y. Listen carefully. Differentiate with respect to y. आतापर्यंत डिफरन्शिएशनच्या प्रत्येक एक्झाम्पल मध्ये आपण डिफरन्शिएटिंग विथ रिस्पेक्ट टू x असं पाहिलेलं आहे. इथं कंपल्सरी चेंज लक्षात घ्यायचं आहे. डिफरन्शिएटिंग विथ रिस्पेक्ट टू y we get. Now differentiate this x with respect to y. That means dx by dy exists. Therefore here LHS becomes dx by dy equal to, differentiate this y square with respect to y. Derivative of y square with respect to y is 2y. Consider this as equation number 1. We know that by theorem on derivatives of inverse function dy by dx is equal to 1 upon dx upon dy. We can use this statement as dx by dy equal to 1 upon dy by dx, and also dy by dx equal to 1 upon dx by dy. Therefore, dy by dx equal to, by equation 1, replace dx by dy as 2y, 1 upon 2y. Therefore, dy by dx equal to 1 upon 2 into root x, replacing here y equal to root x. Hence, the final answer is dy by dx equal to 2 root x. ॲक्च्युली तुम्हाला आन्सर इथे माहिती होतं, जर y इक्वल टू रूट एक्स असेल तर त्याचं डेरिव्हेटिव्ह 1 आपण स्टँडर्ड फंक्शनचा यूज करून इथे आन्सर येतं. बट इन्व्हर्स फंक्शनच्या मेथडने या फॉर्ममध्ये करायचं आहे. इथून पुढे मेथड लक्षात ठेवा. जो y इक्वल टू गिव्हन फंक्शन असेल त्याहून x इक्वल टू टोटल एक्सप्रेशन घ्यायचं, डिफरन्शिएटिंग विथ रिस्पेक्ट टू y, अँड बाय युझिंग थेरम्स ऑन डेरिव्हेटिव्हज ऑफ इन्व्हर्स फंक्शन we get dy by dx. So we will see next example. Suppose y equal to 2x plus 3. Given that y equal to 2x plus 3, therefore 2x equal to y minus 3. Therefore x equal to y minus 3 upon 2. Differentiating with respect to y, we get differentiating with respect to y, we get dx by dy is equal to 1 by 2 is constant, 1 by 2 into bracket, derivative of y with respect to y is 1, as derivative of x with respect to x is 1, similarly derivative of y with itself is 1, derivative of 3 is 0. Therefore dx by dy is equal to 1 by 2 into 1 minus 0, that is 1 by 2 into 1 equal to 1 by 2. And by theorem on derivatives of inverse functions, dy by dx equal to 1 upon dx by dy equal to 1 upon 2. This is denominator of denominator. Therefore, derivative becomes dy by dx is equal to 2. This is the process of finding by method of inverse functions. Now, observe here. If simply given as y equal to 2x plus 3, then what will be the derivative? Derivative of y with respect to x, dy by dx equal to derivative of 2x is only 2 and derivative of 3 is 0. Therefore, the final answer must be only 2. Observe here, dy by dx is only 2. Now, next example is, if y is given as e raised to x minus 3. Therefore, e raised to x is equal to y plus 3. Now, express this x as in terms of totally y. E raised to x is equal to y plus 3. Therefore, here we apply definition of logarithm. X is expressed as log of y plus 3 to the base e. Now, differentiating with respect to y, dx by dy is equal to derivative of log of something. Derivative of log of y plus 3 is 1 upon y plus 3. Since this is derivative with respect to y, therefore the derivative of log of y plus 3 to the base e is simply 1 upon y plus 3. And we know that dy by dx equal to 1 upon dx by dy. Therefore, 1 upon y plus 3. And by simplification, we can write dy by dx is equal to y plus 3. Now replace this y as given. Dy by dx equal to e raised to x minus 3 plus 3 as it is. Simplifying, plus 3 minus 3 cancel, the dy by dx is equal to e raised to x. So the answer is e raised to x. Now again verify here. If y equal to e raised to x minus 3, then what will be the derivative? Dy by dx is equal to derivative of e raised to x is itself e raised to x, and derivative of this 3 is 0. Therefore, the answer should be dy by dx is equal to e raised to x. Here the answer is verified. Now again consider the last example of this type. Y equal to, already y is expressed in logarithmic expression, y equal to log of 2x minus 1 given. Y equal to log of 2x minus 1. Obviously here base must be e. Again by definition of logarithm, e raised to y is equal to 2x minus 1. That is 2x minus 1 is equal to e raised to y. e raised to y is equal to 2x minus 1. Therefore 2x minus 1 is equal to e raised to y. Therefore 2x equal to e raised to y plus 1. Therefore x is equal to 1 by 2 into bracket e raised to y plus 1. Now differentiating with respect to y, dx by dy equal to 1 by 2 into e raised to y as it is. Derivative of e raised to y is e raised to y. Derivative of 1 is 0. Therefore dx by dy equal to 1 upon 2 into e raised to y. This is equation number 2. We know that by theorems on derivatives of inverse functions, dy by dx equal to 1 upon dx by dy. Therefore dy by dx equal to 1 upon 1 by 2 into e raised to y. By equation 2, therefore dy by dx equal to 2 divided by e raised to y. Therefore dy by dx equal to 2 divided by 2x minus 1. By equation 1, replace e raised to y is equal to 2x minus 1. Therefore the answer is dy by dx is equal to 2 divided by 2x minus 1. Now again we have to verify our derivative. Dy by dx equal to log of some function 1 upon 2x minus 1. 1 upon 2x minus 1 into derivative of this function. Use derivatives of composite function. Derivative of this bracket is derivative of 2x is 2 and derivative of 1 is 0. Therefore the answer is 2 divided by 2x minus 1. This is the final answer. So in this lecture we have studied theorem on derivatives of inverse functions and some examples from exercise 1.2. In the next lecture we will continue the exercise 1.2 along with question number 2.